When it comes to the science of light cards, there's two key things that we'd like you to understand. The first is binning, and the second is heat management. Let's explain binning, which is just a fancy term for LED selection. And there's four key metrics that we select or bin LEDs for. The first is color temperature, the second is CRI, the third is brightness, and the fourth is voltage. All four of those are critical in order to create the perfect light field and in order to extend the longevity of LEDs. If you don't bin for these tightly enough, you'll end up with a light field that's spotty or leopardy or mottled. And so when someone says, well, you know, our tolerance is within plus or minus 5%, which is what the industry standard is, what you'll end up with is 3 or 4 LEDs in a row that might be 5,600 degrees Kelvin, 3 or 4 in a row that are 52, 3 or 4 in a row that are 61, and the overall light field is radically different from area to area throughout the LEDs. A lot of makers don't understand that. Photons do not mix. Photons act like billiard balls and they bounce off of each other. So because of that, what you really need to do is bin as tightly as possible, which is what we do. Our tolerances are 0.5%. That's how tightly we bin for all four metrics. And the fourth one, voltage, is consistently ignored by most lighting manufacturers and LED makers. And the reason for that is they don't realize how important it is in order to supply voltage that's exactly the same to each LED in order to make sure that each LED is getting the maximum lifespan possible. The second area that you want to understand is heat management, because heat management is not a simple thing when it comes to LEDs. There's actually 3 different types of heat. You have back heat, which everybody understands how to control. You have a 30-second heat spike, which is the period of time where a traditional aluminum heat sink cannot absorb the heat coming off of the LEDs. And so the LEDs reach a maximum temperature of 260 degrees Celsius, which is more than 140 C above what they should be operating at. So they're actually cooking themselves to death very slowly. And then the third is front heat. Anthem 1 is the only system that I know of that controls all 3 of those. And so the way that we control the heat spike is by introducing a copper front plate in our aluminum heatsink. That copper front plate guarantees that it absorbs the heat immediately as the LEDs are turned on. And so from the very moment it's turned on, the LEDs are not operating above their maximum operating temperature, which is 140 degrees Celsius. Then it dumps that heat into the aluminum pin fin heatsink that's attached to it, and they escape through the system through the fans. The third type of heat is front heat. And front heat is an inevitable pocket, a 5mm thick pocket of heat that sits right on the surface of the LEDs. It's one of the reasons why our plastic components are so thick. They actually guarantee that you can't put something directly on the LED. Now you can touch it with your finger. That doesn't cause any harm. But if you were to say, fasten a piece of glass to the front of the LEDs, you'd actually be refracting the heat back into the system and slowly cooking them to death. So understanding heat management is critical to expanding the longevity of LEDs, and understanding the 4 binning or selection metrics that you can use is how you make a superior field of light that's coming out of your instrument. And so hopefully understanding those 2 things will help you understand a little bit more why Anthem light cards are superior to other LEDs on the market.
Anthem 1. We didn't invent the light. We perfected it.